Reset. Oh, alrighty. I think this is all working, ladies and gentlemen. We're going to get started here in just a moment. Unreal is loading, and there it is. Takes its sweet time sometimes. It is not working, ladies and gentlemen. My window capture is decided to capture not my monitor, but rather my desktop. Give me just one moment. Should be able to switch this over like so. Lovely. All right, ladies and gentlemen, we're going to get started here. I don't know if you all can hear me. You should be able to. And we will be getting an Unreal project started here. The goal of this project is to have a centralized engine similar to D2X or DXX Rebirth or D2XL built in Unreal Engine 5 for the Descent series, not just Descent 1 or Descent 2, but all three Descents. The Descent 3 source code was recently released, and so that will enable us to set up a system that can load in levels from any of the three Descents, and we can have a modern input handling system and a modern rendering system, but with all of the old Descent campaigns that you're used to. Now, as you can see, we are just getting started here. So we're going to be going through kind of the whole process of building a Unreal Engine game. So I also hope this to be a bit of a tutorial series for people who are interested. So this is the starting blank blueprint project in Unreal. We're going to kind of get started. This is an open world level, and this is fine for now. Really, the first thing that we're going to do here is get a game mode set up. So with Descent, we don't have a standard character object or a standard FPS character. The Descent character ship flies and doesn't behave like a bipedal character in general. Typically has a spherical collision model, a few other quirks that make it so it doesn't work or make it work a little differently as standard character object. And so we can't use the default built-in controller pawn for Unreal Engine. And I realize that's some technical statements. We'll get into what a pawn is in a minute. And instead, we need a new pawn. We need to make a game mode that will point us to a different pawn. So let's start with that. We're going to go to our content drawer, and we're going to make a new blueprint class, I think. Oh, this is funky. I can't actually see the pop-up on my screen. I can see it on OBS, but not my screen. That's very odd. Very, very odd. Well, shoot. I'm gonna switch out of. I'm gonna try deleting this window capture and see if that gets me back some stuff here. So it'll just be black screen for a minute, gentlemen. Oh, I see. I see. Okay. So the reason it looked like, wow, that's a mess, isn't it? The reason it looked like it was just in OBS is because it opened it on the other monitor. Derp. Game mode base. That's what I'm looking for. We're going to call this dev mode. And while we're doing development, we'll be in this development mode blueprint class. And as we get into the actual game side of it, we'll make new classes that contain different win conditions and handling stuff like that. So let's go ahead and open this. Perfect. Let's save this. All right. So this is where we can choose our various classes that we want to use. Right now, we're really just looking to change the default pawn class. Eventually, the player controller is all fine. Okay. So a game mode class kind of defines what should happen when the level starts, what should happen or what should cause a level to end, how to keep score, that sort of thing. And you can see that we've got all these events down here that we can use to track things that happen in our level and keep score with them. I'm going to close this for now because we don't actually have any of these things for our we don't actually have custom versions of any of these things yet. We need to add those. So we're going to go back to the content drawer. Generally, what I'm going to be doing here is just adding the content kind of in the root folder, and then as necessary, I'll be adding folders to organize my stuff, kind of starting from the ground up and getting more abstract as we go. All right, we already have a player start in our level. That's great. We can leave it right there. So now let's go ahead and add a, we want to add a pawn. So in Unreal, a pawn is the thing is a object with movement characteristics that can be taken control of by some sort of controller. That sounds very complicated, but basically it's an abstract way to represent something that can move and take actions in a level. And the reason it's abstracted like that into a pawn and controller and all these differently named things is because is to make it easier to create AI and to create remote players and to create multiplayer. So if I have a pawn separated out from a controller, then I can define my movement in one place, and then I can have multiple different methods of controlling that pawn, but that pawn will still have the same movement no matter what. So we're going to go ahead and we're going to derive from the pawn class instead of the character class because we're making a Descent-like game, and a character class assumes a bipedal character. Descent has a ship character, so this is wrong. So we're just going to call this base ship. Now, yeah, this is going to be our basic ship, and we basically want it to have a camera and a spherical collider and a static mesh. We want to be able to animate the mesh later, but that's what we want to start with. All actors, all classes in UE5 have these pieces of classes called components. And you can think of components kind of like interfaces. They're going to define a thing that must be in this class. So every base ship right now doesn't need anything, but I can say I want every base ship to have a camera. Ta-da! Now it has to have a camera. We're just going to leave this as camera. And then I want every base ship to have a sphere collision. And we're just going to make this size a little bigger than that. Great. Now we have a camera and a sphere. Yay. Now, right now, this sphere collision is attached to the camera. That's backwards. We don't want that. So we're just going to click and drag this on up above the camera. I don't know if we want to make this the root. Okay. Both the sphere and camera are now below the default scene root. But I'm not certain if we want to make it like that. And a good way to figure out if we actually want to make it like that is to look at examples. So I'm just going to save this and go ahead and close this. And I'm going to actually create a new character blueprint class because that contains a working pawn that I really want to kind of base my new pawn off of. And we're just going to open this and take a look. So in this example, we have a capsule, an arrow, and a mesh. No camera, interestingly enough. I would expect there to be a camera in this. Either way, you can see the capsule component is the root, which probably means we want the capsule component to be the root. Character movement component is the big thing that separates out characters from pawns. We won't be using that, although we might look into creating a custom pawn movement component later. As you can see, this is a C++ source, and we're just going to start out prototyping our system in blueprints. It will be a bit faster for us. C++ is much faster when you get into more complex stuff, but for doing civil prototyping, blueprint is going to be faster. So, spaceship. Go back to our viewport, and we are going to make the sphere the root. And we are also going to go ahead and add a mesh. For now, we are going to set a static mesh, but it should be noted that it might be a better idea to make this a skeletal mesh. We do not have any static meshes in our scene, which actually makes sense. We've not imported any. Okay, we don't want anything in construction or script right now. The event graph is where we're going to be doing our coding. But before we start doing our coding here, we are going to use event tech, but I don't think we're going to use we're actually going to be using all of these, but not yet. Before we start doing our coding here, we need to first set up our input. Right now, our game doesn't have any input set up, so we need to go to our, I believe it's in our project settings. Yeah. Project settings, let's see here, where is it? Enhanced input. Okay. Now, I don't actually, last time I used Unreal Engine was before the enhanced input, so I'm going to need to figure out exactly how to use these. Let's see here. Add element. Ah. Okay, I'm not quite sure. Whoops. Enhanced input. Well, it has something to do with these elements. Ooh. Okay, I think we need to create an asset here, and I'm not sure what asset we're going to need to create. Let's drag this up a little bit so we get a bit more room. No. Input. Input mapping context. I believe because it's yellow and the thing we're looking for is yellow is we're going to call this dev input. We might change this later. Ooh, mappings. What are we looking at here? Let's see. Let's see. Whoops. Gotcha. Modifiers. Interesting. All right, so we have chorded action applies a chord action unless we triggered for this action to trigger. I assume that is multiple keys. Combo, okay. When the trigger exceeds the actuation threshold, when no triggers are bounced down, are bound down 0 is default. Hold and release, pressed. Fires once when we receive the pulse. So I think we want down. Oh, actuation threshold 0.5. Okay, so what we've done is we've created a axis that is mapped. You create an axis that triggers at 0.1. This is all a little bit weird, but sure. I'm about to figure out what all this mapping is. And then we have mapped this axis to W. And confused me to no end. So we don't have to use. Interesting. I'm very confused as to why I have multiple triggers here. And I'm also confused as to what these triggers do. So previously in Unreal, you'd create a trigger and then you'd say, well, this trigger maps to this input name at this value. And I'm seeing a way to create input names, I'm seeing a way to create triggers, but I'm not seeing a way to create input values. Ooh, it doesn't like something. A mapping cannot have an empty input action. Ah, good to know. My player map key settings must have a valid name. There cannot be a null input trigger on a key mapping. So it wants there to be input actions here. Okay, so we're probably going to delete this action or rename it. Oh, okay, so we're going to call this do we want to call it XYZ? We'll call it player X. I'm very confused about the triggers. I'll have to rename this. Whoops. Okay. Let's go ahead and close this. And this. Player X in. And well, player Y. Player Z. Player roll. Player yaw. Player. What is it? Roll yaw and pitch. All these, I believe, are going to be one-dimensional axes. Yes, 6 1D axes, and we're going to just call this pitch. I'd like to open all of them, please. It's a 1D axis. We're going to call this roll. Whoops, roll. We're going to call this X. 1D. Y. 1D. Save. Save. And yeah. Oh. Yeah, that's fine. This is also a float. Okay. All right. Now, as you can see, that has made our content drawer a little bit messy. So we are going to create a new folder. We're just going to call this input. And we're going to take all of these. Uh-oh. And it's basically telling me I'm going to need to refine the dev input in my settings, which we can do. Enhanced input, there we go. All right, so so now we have W and S on player X, and what we want to do is triggers down I'm confused as to how to set the value here. Right, but I want, maybe we modify and inverse input per axis? Something like that? I don't know. I think it's time to look up some documentation. So I'm going to be pulling up enhanced input. Okay, so enhanced input for UE5 projects and requires more advanced complete enhanced input. Well, actually, this is for all UE5 projects now, since normal input is depreciated. Excuse me a moment. I just realized, have I been off screen this whole time? I have, hadn't I? Derp. Allow me to fix that. Ta-da! Hi, I'm back. I don't think anybody's tuned in yet. That's okay. This one, it's features like features like radial dead zones, consensual process, aspect environment. When you use the hat input, you can add and remove mapping context at runtime for the player. This makes it easier to manage a large number of actions. For example, we player that can rock, spin, and prone. For each character movement types, you can swap the mapping to have a control key do different actions. While walking, pressing control key, you should crouch. While sprinting, pressing control, you should slide. While prone and pressing control, you should stand back up. I'm confused how this is different than before. Okay, so enhanced input enabled by default. You can create assets inside the content power by clicking add. Yeah, we got there. Input actions, input mapping context, input modifiers, input triggers. An input action is the communication link between the enhanced input systems and your project's code. Fair enough. Input actions are conceptually equivalent to action and access mapping names, except they're data assets. Each input action structure represents something that the user can do, like crouch or fire weapon. I think I'm going to rename my stuff to, instead of player X, or like move X or rotate, yeah, pitch, roll. That's something that I'm going to have to figure out, is how do I want to name that? Do I want to do move front back, move left right, move up down? Or do I want to do move XYZ? I don't think I want to do rotate XYZ, because the rotate XYZ is figuring out what's X, Y, and Z in rotation is pretty tricky. Because, like, well, it's not that tricky. X, Y, Z. For example, Z is yaw, X is roll, and Y is pitch. I think I want them to be named. I think that's going to be easier. Less thought on it later. So I think I'll do that. So input actions are linked between or fire weapon. You can input listeners in Blueprint C++ to detect action changes. Input actions can be several types of values. You can make booleans or a more complex 3D axis. The type of action determines the value. Boolean actions have a simple bool value. A 1D axis is a float, 2D, 3D. Okay, that makes sense. You should use Boolean actions for on-off inputs. That makes sense. For controls like game state func values, you can use 2D actions to hold the X and Y values of the thumbstick positions. That's very odd to me. If this is an action that we're doing, why would we encode the whole action? Or why would we encode... Should not we be encoding this not based on the input, but based on the actions? Right? I would think that we would never use a 2D axis. We'd use 6 input, or we'd use 2 inputs with 1D axes. Why would we use a 2D axis? It's very odd. Uh-huh. So the biggest confusion I have is how input mapping context works. So let's take a look. An input matching context is a collection. So actually, let's go back a little bit to our vectors. So basically, based off of how these vectors are described, I should be using a pair of 3D axes. I should use a move action and a rotate action. Or a move and a look. Possibly a move and a look. There's some stuff we might get into later on. There's going to be multiple types of looks. I think we can encode that contextually if I'm reading this correctly. Where we have the standard descent look, which we'll implement first, obviously. But we might also have a uh, uh, kind of FPS style look where you have a trigger to reset your rotation. So you can look in the normal FPS style that everybody's used to, but if you're getting gimbal locked, which is the correct term here, yeah, you get a gimbal locked by you're looking up and you now need to do some weird rotations, you can press a key and that up will now become forward. And then you can rinse and repeat all over again. And this will make Descent more accessible to people, even if you'll never get very good doing that, but you'll be able to play on medium difficulty probably just fine. Possibly even a higher difficulty, but some of the 3D stuff you can do in Descent is really incredible. So I don't think you could really do very well in multiplayer doing that. But it's something we want to offer for new players, particularly players who get motion sick. Okay, input matching context are a collection of actions that represent a certain context that the player can be in. Okay, so based off of this information, I would have that would be two different input mapping contexts mapped onto the same actions. I have no clue how that would work. Because I would have to... Yeah, I'd have to do some very weird stuff with the mouse for that to work. And the joystick, actually. Don't know. Okay, so input matching contexts provide a collection of input actions. Describe rules. Yes, we know how to add them. Is a hierarchy with a list of actions at the top level. Under the input action is a list of user inputs that can trigger each input action. So we could have okay. So for example, we could have mouse and joystick here for rotation. Mouse and joystick and keys for rotations. Okay, if we're supposed to collapse walk into, or move in this case, fly into a single input action, then we would put 6 keys, a joystick, and a mouse. Unless the joystick and mouse can be considered the same thing. A joystick, a mouse, and maybe even a controller under mappings. Okay, so input modifiers for each. Okay, so the bottom level contains. Okay, so the basic structure of input actions, list of in the input action, list of inputs can trigger each input action as keys movement axes. Looks like movement axis is more generalized, so I don't have to do joystick and mouse. The bottom level contains a list of input triggers and input modifiers for each user input, which will determine how the input's raw value is filtered or processed and what restrictions must meet in order to drive the input action at the top of its hierarchy. Okay. You can apply one or more of these contexts to the local player through... This is where you implement your actual key to input action bindings and specify additional triggers or modifiers for each action. When you add an input mapping context, you can also give it a priority. Sure. If you have multiple contexts and map to the same input action, when the input action is triggered, the context's highest priority is considered and the others will be ignored. Interesting. What if I just want the last input? Okay. As an example, swim, walk, and drive vehicles with multiple input mapping contexts. Right, sure. One of the common actions is available and always mapped to the same user inputs. One for common actions is available and always mapped to the same user inputs, and another for each individual mode of travel. Okay, sure. Developers can then place vehicle-related input actions to a separate mapping context, which is then added to the local player when entering a vehicle and removed from the local player when exiting the vehicle. Also, sure. Doing this helps optimize and prevents bug, ensuring that inappropriate input actions cannot run. Also, using multi-exclusive informatic calls will avoid input collisions. Will never accidentally trigger the wrong action. Okay. Begin play. Cast player controller. Add mapping context. Sure. All right. Input modifiers are preprocessors that alter the raw input values that the engine receives before sending them on to input triggers. Okay. Okay. I am confused. Da, 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 da. You can also create an input modifier, create new using input modifier as parent. Override modify raw. Okay. Okay. A good example of an input modifier using a single input action. Okay, great. This is actually exactly the question I had. How do we use keys to do a single input action? So, um, with the mouse or gamepad analog stick, reading a two-dimensional movement is straightforward, right? We have two-dimensional movement in both of those. Enhanced input supports inputs from one-dimensional sources, right, like WASD, and you can achieve this control scheme by correctly applying input modifiers, specifically by using a negate to cause keys to register negative, and using swizzle to make some key registers X or Y instead of X. Another reason not to use XYZ, Unreal is the only system I know of that uses Y as forward backwards. Everybody else uses X. It's really weird. Alternatively, they use Z. They either use X or Z because it depends on if they're having Y up or Z up. Maybe I'm just uneducated there, but it strikes me as very odd. Okay, so especially because the default axis value is XYZ. So why would you have the first value be left right? That makes no sense. Anyway, so W up positive X. positive y. So we have to swizzle. Okay, left, negative x, so we just negate. S down, negative y, we negate and swizzle. And then D, positive right, we don't do anything. Okay, okay, I think this all makes sense. Let's go back to our input and actually do that. So, down, actuation threshold 0.5, that shouldn't really matter that much. But modifiers, we want to do swizzle. Swizzle, whoa. There we go. Yes, swizzle correctly. S, we want to negate and then swizzle. Once again, that's fine. Then we want to add A. Oops. A. And keyboard A. And the triggers is down. I think we can remove the triggers, but we want to just negate. And then, whoops. Okay, that's correct. And then D, just down. Like I said, I think we can delete the down elements because the default is down 0, so this is just fine. And as we noted, we are going to be renaming player X to move and renaming one of the rotations to just rotation and ignoring and deleting the others. We're just going to simplify things greatly. But that does mean that we need to add a couple of, right now we're just going to do my preferred key mappings, which I don't think will run into anything. We're going for left. Nope. That's a rotation on my preferred key mappings. My preferred key mappings is to put the up and down on the hat on the joystick, but I don't have a joystick plugged in right now. So we're going to go ahead and this is going to be a swizzle, and we are going to swizzle this not to YXZ but to ZXY. I think that's correct. And then we are going to add one more. This will be E keyboard, and we are going to swizzle. We are going to negate this one and then swizzle. Swizzle, that's a fun word. And of course to Z first. It doesn't matter what the XY is. It's just, I hope it doesn't matter. I'll be very confused when it does matter, and we'll come back and fix it. All right. So we're going to add new mapping. Whoa. New mapping, and we're just going to grab pitch. This will just turn into rotation. And then we're going to do mouse. We'll do mouse XY. And this should we're going to delete this. Oh, whoops, delete the wrong thing. That's okay. Pitch, and we're going to do mouse X, and we're also going to do mouse Y. X shouldn't need to be swizzled, Y should be swizzled. And the reason that we're going to do that is it's not clear. Correction. They both need to be swiveled. Okay, mouse X needs to map to the Z-axis of rotation. Yeah. Local Z rotation. So, what are our triggers for this? Same as before. Just delete that. So, swizzle and X should go to this, I think. And the reason that we're mapping that separately from mouse Y is some people actually prefer roll on X instead of yaw. And so even though we're swizzling to Z, it also might make sense not to swizzle this at all. Which I'm not actually certain how to make use modifiable. We'll figure that out later. I'm assuming mouse Y is a one-dimensional axis, X, Y, Z. But I don't know. So this might get interesting. Y, we want to rotate on X. Oh, so we don't want to swizzle it. Right. Of all the thing weirdness. Okay. Player pitch. We are also going to add a couple of default mappings here. We're just going to do shift, left shift. And we're going to add space. These are my just default mappings for rotation. We probably need to add, when we get to user input, we probably need to add 6 keyboard mappings here and 6 keyboard mappings and then some sort of multiple axis mappings. Probably 3 axis mappings. I'm wondering about analog keyboards. Right? How do you set something up so that you have an axis mapping on so that like when you press space in a little bit, it rotates slowly, and you press space in a lot, it rotates quickly. And then you press shift in a little bit, it rotates the other, well, let's do this, the other way slowly. Yeah, it's basically, it rotates quickly. Right, so shift, space. But with analog keyboards, you should be able to modify that like an axis. So, and that sounds like 6-axis values, but I'd like some way to map that. I wonder if the user has a screen like this where they can add and remove stuff, right? Because if you can add, anyway, I'll have to play around with it. Okay, so left shift. I have no clue if left shift is positive or negative. And it is rolling on Y. So we want to swizzle to Y. And spacebar, I'm just going to go ahead and start by negating it to make it the opposite of left shift. And then swizzle to Y. Okay. So I don't know if I've got my rotation correct, but they'll rotate the opposite way, so it might just be inverted. All right. So we have 1, 2. All right. So we got 1, 2, 3. Whoops. 4, 5. 6 axes mapped. All right, we're going to save that dev input, and we're going to head to our, did I minimize that? Uh-oh. Yes, I did minimize that. I want to close that. We're going to head to our input content. We're going to change this to rotation. Ship shift rotation. And we're going to change this to... I don't know if I want to name it that. Let's just name it in rotation. And then player X, we are going to rename this in fly. We're going to name this in flight, sorry. Trackball. We're also going to name this in rotation trackball. I don't know if I want to do that so early. Right? Do I want to just do... we can rename them later if we need to. And then these get deleted. I am certain I want to delete. Okay, so we've got fly and rotation, both on the trackball in traditional descent style. I think that's correct. Yes. So for reference, a turntable and trackball come from 3D modeling software, and they typically reference a camera rotating around a point in space in front of them. Let's see here. Like this. This is a turntable style rotation in Unreal. This is also a turntable style rotation, but it's in an FPS mode, so the camera's rotating around itself instead of a point. I don't know how to turn on trackball style rotation in Unreal. I don't know if that's a thing. But I can pull up Blender here and switch it here. Edit, preferences, viewport. Editing. Navigation, there it is. So right now we're in turntable, and like so, looks like just like the Unreal. And if we change it to trackball, it lets us rotate in true 3D, but it can be much harder to control, particularly when you don't have, particularly when it's just the mouse, when you just have 2D inputs. I would actually be perfectly fine with trackball if I could manually rotate, manually roll. Anyway, that's going to mess me up, so I'm going to switch this back to trackball here, or sorry, turntable in Blender, which is what I'm used to. Okay. So now, after all of that, we can finally get started on our pawn. All right. So the first thing we want to do is add a in rotation trackball event. We also want to add an in fly. I did fly. An in fly trackball event. So whenever we get input from rotation or flight, we get events. Although and when we do this, we want to add to our velocity. Usually we want to work at a high level as possible when doing any sort of physics, uh, and that's just to make it easier to replicate over the network. So I know there's such a thing as a pawn movement component, floating pawn movement. So we have floating pawn movement. We have interp2 movement, projectile movement, and rotating movement. Let's take a look. At the documentation for wait, where was all this before? Add an impulse to a friction body. That's not what we wanted. Oh, did I spell velocity wrong? Let's see here. Get physics linear velocity. Set all physics angular velocity. Set all physics? Set physics. I didn't think static mesh had any physics on it. Set physics angular velocity and set physics linear velocity. It's fair. Ah. Whoa. Okay, so that's weird. Oh, because I forgot to change the save this. I forgot to change the input types on these. These are now 3D vectors. Save that. 3D vector. So now we can drop this into here. And so, where did I find that? Was that under pawn? Components, pawn movement. Odd. Why is this? Why is this? Um, why is this three things instead of one thing? I think our target is this. Oh, weird. I'm very confused here. So, we're going to look up the documentation for this guy. Floating pawn movement. Firefox just crashed? What just happened? Nope, that was weird. Oh. Right. Much better. Windows in Unreal sometimes handle oddly. So even though Firefox was the priority, I clicked through to the Unreal window somehow. All right, so floating pawn movement, inheritance from EU pawn movement component, which I couldn't add directly. That's interesting. Movement component updates position of associated primitive component during its tick. Floating pawn movement is a movement component that provides simple movement for any pawn class. Limit on speed and acceleration are provided while gravity is not implemented. This sounds exactly what we want, but it also sounds like rotation is not implemented. So we have acceleration. That's interesting. Position corrected. Deacceleration. That makes sense. Okay, so these both make sense. Acceleration, deacceleration, max speed, turning boost. Okay. Okay, yeah. Functions. Oh, apply control input to velocity and limit world bounds. Also applies gravity. Gravity is not implemented. Okay. Update velocity based on input. Also applies gravity. What happens when I click on this? Nothing. Okay. Pawns go and look for food. Ooh, it looks like I'm going to have to rebuild nav mesh behavior for 3D pawns, which kind of makes sense. Because you can't exactly nav mesh in a volume. So I'll probably have to do some sort of graph, navigation graph to points. That would make the most sense. Actually, to start with, I can replicate the AI from Descent, which I'm pretty sure Descent 1 and 2 use some sort of navigation graph based off of nodes, because Descent 1 and 2 are cube-based levels. So you can have each node in the navigation graph is a cube, or is a point in the center of a cube. Don't know what you do for concave cubes. Well, yeah, concave cubes though. Anyway, not sure you could have concave cubes. There might have to be multiple cubes. Anyway, I have to look that up. Pawn movement component adds a given vector to be accumulated in world space. Oh, I need to transform this. I would need to transform this vector into world space before adding it. Consume input vector. I'm starting to think that I might not want to do a movement component to start with, and I just do the movement on the pawn. Well, let's try that real quick and see what we get. Delete. And of course, that needs to be deleted. Nope, wrong button. Okay, so we probably need to add some variables, actually. I'm thinking about it. That's, yeah. So variable, we'll call this world move. And this is going to be a vector. And, or world fly, I guess. Fly world. And then this is going to be rotation world. And it's not going to be a vector, it is going to be a rotator. Is it going to be a rotator? I think so. Okay. So, when triggered, we need to rotate to world. We want to get rotation. Wow. It's weird this didn't show up when I typed get rotation. Do I have to type get world location. That's very well. Rotate, rotator, break into axis, combine rotators, delta, invert, lerp, select. So what we're looking to do is to rotate a vector, this by this. I'm pretty sure this is wrong. And then we're going to set fly world. I think we actually want to add it to fly world. Nope. To this. Okay. Uh, yeah, I want to rotate, not transform. In this, I want to construct a rotator. Unrotate vector. Is that how I want to do it? I'm not certain. Let's let's do that later. Let's Oops. That's not what I wanted. Okay. This should be used cautiously. Maybe better to use add force or add impulse. Really? That's an odd statement. That is not what I would expect. Add a single force to add a force to a single rigid body. Good for adding burst over time. Should be scaled every frame. Should be called every frame for the duration of the force. We're going to multiply this by delta seconds. Oh, sweet. They handled that. And then we're going to multiply by force scale, and this is just going to be a float. And I suppose 0 to 1,000. How do I set the default on it? Oh, I need to compile this somehow. Oop. Set this to 0. Ideally. So every tick we add a force, and then set our thing to 0. But every input we set our thing to this rotated to the world vector. And then, of course, we multiply phi world by force scale. And, of course, we want to compile this. I want to play. I just want to... There it is. Compile the blueprint. So I can go down to force scale and set default value to like 100 or something like that. And hopefully this means that when we go ahead and get this started, we need to, of course, change our default mode to use the base ship. Compile, save, close this, and then we also are going to want to change our default game mode to dev mode. So now when we go to play this, we should be using our pawn, which we definitely are because it's not working. Okay. I don't know why it's not working, but it's not working. We are going to hold down W for a while. Nothing? Still nothing. Okay, so it's actually not working. Okay. We're just going to delete this set to 0. This should have funky behavior, but it might be more reliable. Nope, nothing. Okay. So, I suppose the first thing we want to do is, can we print? Okay. So basically what we're saying is if we're actually getting a input, we're going to go ahead and print that input, and that will tell us if, give us some idea of where our errors are. So, I'm not getting any input. That's interesting. I don't know if that would have changed anything. Okay. Did I miss something here? Do I need to set this in both places? I'm not getting any strings printed to the console. If I go to my event tick and I just add a Print string every tick. Let's make sure we're actually seeing the print strings. Oh, hey, Nashcats, thank you for the raid. We're just trying to code up here a little Descent clone for those of you who are viewing. Ideally, what we want to get to the point is Descent is a video game, released in 1994 originally, and we want to get to the point where our little Descent clone can load levels from Descent 1, 2, or 3 and have kind of a common interface for playing each of those levels and a maybe development platform for future development. It's just a fun little personal project right now, and as you can see, we're just getting started, so we'll see how it goes. Right now, we're being confused about UE5 input. Good, print is working. But if print is working, then input is not. Okay, so enhanced input. Oops. I don't actually know how to break one of these. Suppose that's one way to do it. Oh, whoops. This should go here, and then this should go here. There we go. That might help. Although I'm confused as to why I wasn't getting input on X and Y whenever I turn right, whenever I move the mouse. So at least we have the right input now. Okay. We are still not getting input. Okay, game is booting on my other screen. It's going to take a minute. And still nothing. Where'd you go? Okay, so input is not working. Now we're going to switch back to selected viewport because I think that's going to be easier. Okay, why isn't input working? Let's head back toward our enhanced input documentation, I guess. And do some more reading. Thank you, Nashcast. I don't know if I'm actually any good at this, but I hope to be entertaining, at least. All right. So, input triggers, platform settings. They don't actually say anything about getting input here, so let's do a little bit of Googling here. UE5 enhanced input event not triggering. Okay, simple test project, blah, blah, blah. What's this guy doing here? It looks like he has a custom player controller, maybe? Enable input. Okay, looks like he's having the same problem as I am. Interestingly enough, this guy has some stuff in the player controller blueprint. I don't recall seeing anything in player controller blueprint about this. That is most interesting. We can go ahead and try adding ourselves our own player controller. That's simple enough. Or maybe we just need to enable it here. Wow. How did he do that with the player controller? Oop. Okay, it looks like he's just getting the local index. That's a really bad way of doing it. He needs to enable input in the player controller blueprint if he's doing it that way. But it works for a test. So let's roll. Save, compile, and test. Nothing on input as expected because that doesn't make any sense. Okay. So let's go ahead and make our own player controller and see if that helps things. Let's actually, before we do that, my bad, did not want to do that. Before we make our own player controller, let's read through the responses here to understand what's going on. Don't use a tap modifier, tap only reacts. Yep, we're using key down. Okay, we need to make sure our game mode has the correct player input class. But we're using a UE 5.4 preview, so that's probably not going to be an issue. You don't need to enable input. Okay. And it looks like we might need to go ahead and add a mapping context here on our player controller class. All right, let's head to, what's that? Don't know what that is. Let's head to our dev mode. Let's see here. So default input class. Oh, are they talking in the editor settings? Or in the project settings, rather? Default editor input class is enhanced player input. Okay. so that's probably not an issue. So yeah, let's go ahead and make a new player controller. Base player. I'm going to save this and pull this up and head to our event graph. On begin play, we want to, what was the node called? Add input context. Context, nope. Mapping context, add mapping context. I'm not seeing it. Oh, let's turn off context sensitive. Let's just do mapping context. Add mapping context. Okay. That's not what I'm looking for. Mapping context dev input target self. I'm not certain about that target self. Yeah. Target must have a connection. How do I get that? Enhanced input sub system. Get I don't know how they got self. Like, it should be obvious. Huh? You liked it. Local input player subsystem. Ah, so much better. Get a reference to self. Okay. That's just going to make it far more clear what's going on. Client only. Yeah, that makes sense. Save this. Compile this. Close this. We also need to change our player controller to base player. And then hit play. And we'll see if that comes through. Would you look at that? I'm still not moving though. But hey, at least we're getting inputs. That's a good start. X1, X-1. We probably need to reset those when we're done. And what I have, Q and E for my Z's. Yep, that all looks good. Save this, please. Okay. Don't think it's saved, but that's okay. We'll save it later. Oh, I didn't want to open base player. I wanted to open my base ship. So that is something that's really good to know for the new. Nope, we don't need this. I don't think. For the new enhanced player input here in UE5, you do need to have. You need to attach it to your player controller for it to work. I think they mentioned how it was versatile to attach things to. The attachments were versatile in the documentation, but didn't mention that there must be an initial attachment. That you'd think that would be obvious, but hey, it wasn't. So maybe that's a documentation enhancement that we can get in the future. Okay, so what do we got going on here? So we are setting this correctly, but we are not. I suppose the first question is, are we setting this correctly with the rotation? That's easy to check. And then we are not adding an appropriate amount of force. If true, force is changing instead. Oh, yes, absolutely true. True, spelled correctly. Oh, there's my check mark. Dark mode got me. So this is probably going to be way too much, but hey, we're going to have fun. I'm not getting anything. Okay. So I just noticed I also wasn't getting anything different on my rotation, but that makes sense because I'm not rotated. So, adding force doesn't seem to be working. And I don't know exactly why. So we're adding force to a sphere. We are, of course, turning the welded, and we aren't returning any bones. And the camera is attached to the sphere, so even if we had issues with that, we would expect it to stay with the sphere. So what we can do, we don't need this anymore. What we can do is perhaps we'll delete this for now. It doesn't like us using set physics linear velocity. We are going to drop this down to 10 because we could get moving really fast here if we don't do this right. You know, I'm wondering about something. Is this the right time to multiply by delta seconds? I don't know about that. I think it is, but that could result in very small force values. So let's try without multiplying by delta seconds. And that's still negative. Okay, so now we really will use this. Set this over here for now and then pretend it doesn't exist. Okay, we still aren't getting any movement. That is odd. That kind of leads me to believe that we are getting movement or we aren't spawning correctly. We are spawning because we can print from this function. Okay. Our scale is 10,000 by default. I think. Let's actually print this. Sorry, print from here. And if we do this, whoop, do this to this, it'll convert it automatically. And let's make sure that this force scale is actually getting set to the default value. If it is not getting set to the default value, then we could be multiplying by 0, and that could be why we're not moving. Okay, it is not working. Or rather, the force scale is working just fine, but the setting linear velocity is not working just fine. This doesn't make any sense to me, but for good reason. Oh, whoa. What did I just do? Not the right thing. I'll delete that. Okay, go ahead and get a reference to sphere. Okay. So this is working, but we are not moving. Why not? Okay, so this is a simple collision. Static mesh component. Sphere collision is doesn't define what it is. I think it's time to look at our example character again to kind of see what is going on. What just... There we go. So capsule component is a collision cylinder. And so this variable name, capsule component, tooltip, category, component class, I suppose. That's odd. Okay. Tick steering physics. Physics. Oh, This button might be important. Just a little bit. You know, simulating physics on a physics-based character might be useful. I bet that's checked in our example. It's not checked in our example. Oh, I am confused now. I bet that's the issue that we're having, but that makes me want to pull up the C++ for character component because that sounds like it's it is setting the uh, the the location manually, which is really interesting. I see why they would do that, but it's still interesting. Basically, you want to simplify your network as much as possible. So, by setting location manually and then only doing actual physics with collision and bounds checking and all that, when you need to, it makes the physics work much better over the network because, for the most part, you aren't actually handling collision or bounds checking or any of that stuff. You're just doing it occasionally when the character gets close to something. Okay, so with simulate physics checked, and I run this, do we get movement? Oh yeah, we get movement. It's definitely the wrong direction of movement, but we can work that out in a sec. I think that's actually the wrong camera direction. Let's go back to our viewport and select our camera. Camera seems to think X is forward, so we might have to change our inputs. But what do we want to do for our movement? Do we want to set the position manually? I think we definitely want to look into doing that. But that'll be a tomorrow thing. For now, I just want to go ahead and get our basic ideas of movement working, both on velocity and rotation, and we can do that using the physics system. It's going to be much simpler to initially set up, and then when we are finished with that, we can then after we've gotten that all figured out, we can then go ahead and transfer that to a movement class that can handle all of the different movement ideas and get rid of our physics system, which is a really intriguing possibility. Okay, so this should, there's no acceleration here, but it should move me. Why am I falling? Does everybody else see that? Oh, because I've got physics simulation turned on, therefore I'm simulating gravity. That makes sense. Let's go ahead and head back to here and set this to a higher number. And then go back to our sphere. And in our physics simulation, we're going to turn gravity off. And that will prevent me from falling. Okay, very simple. I'm still going the wrong way, but that's fine. For reference, I'm pressing W right now, and I should be going forward, not sideways. But the A and D keys go forward and back, and that's fine. We can figure out how we want to handle that later. For now, this is good, but we now need to add in rotation. That's going to be the hard part, I think. Okay, so let's do a little bit of organizing here. Let's go and select all this and pull it up. Whoops. Select all this and pull it up here. So what we're doing is we are simply rotating our rotating a vector by our world rotation and setting that vector, and then each tick we're consuming that vector and setting it to 0. That, I suppose, that would be what consume means. So when we get a rotation on the trackball, that's more interesting, because ultimately we want to set rotation world. Okay, and this will decide the rotator we want to use to set the physics angular velocity, correct? Set physics angular velocity. I think radians is going to be better. Oh, new angular velocity is, is a vector. That's interesting. Yeah, that's fine. I don't think this is going to work, but we'll find out. And we want to, of course, set it back to 0. I think I need to somehow transform this from local space into world space. And I suppose that would just be the same as up here, wouldn't it? But I think that angular velocity is going to be confusing. So let's find out. Okay, we have our movement. That is definitely not quite right. How am I rotating on this here? Okay, yeah, I need to transform this into world space. This is still rotating based off of this. Actually, it was rotating a different direction when we first started. Okay, so that should be just this exact thing right here. We're just going to rotate this vector by our current rotation and set it. And that would be correct. This is not the right axes. Let's go ahead and fix the axes. We're just going to fix them in input for now. I think I don't know exactly what the axes looks like, but if we fix them in input, we'll know what axes we're looking at, and we'll understand if we want to use different axes in our planning. So this is going to go here, and rotation, the left shift ended up swizzling instead of... Okay, so mouse Y with no modifiers ended up being roll. So we do not want to modify this one. And we just want to negate this one. And then we do want to modify this one. Oh, I should check this swizzle before I... What's this one swizzling to? I think it's actually swizzling to the right thing, if I recall correctly, Z by X. So we want to swizzle this one. Swizzle. Whoops. To YXZ. All right. Is that the correct rotation? It's inverted. But that feels correct to me. It's very fast, too. Okay, so let's correct our WSD now. W... A is negate. D is nothing. So... I think I want... So W needs to go to A. So no negation, but a swizzle. And... Ooh. Okay, that just messed me up. Okay. W has nothing, and S, whoops, and S is negate. And then D is negate and swizzle. Ah, D and A are backwards. Okay, so D is not negated, and A is negated. And I actually want to... The first one should be negate, and then it should be swizzle. I think. All right, so we got forward, backward, right, left, roll, up, down. Whoop, that's inverted, so we should fix that. And then right, left, and that's inverted. So that would be mouse Y that is inverted. So we need to add a negate. And once again, we want to negate and then swizzle. Just for consistency's sake. All right, forward, backward, right, left, up, down, left, right. Roll. Nice. So one problem here is that this is effectively infinite speed, right? You can move as fast as I can move my mouse. There's some... I'm actually kind of surprised it works like that because I'm setting the linear velocity not the rotation. So I would expect that to be a little different. But it feels as fast as I can move the mouse. And what I really want to do here as we go forward is make it so that the ship has a max rotation speed and it rotates towards the mouse input. Yeah. I don't know if I want to do that with the... yeah, I want to do that with the linear input too, because you don't want the client to be able to say, I'm moving my... I'm using a mouse for my my linear input for my forward backwards, and my mouse is now moving at 300 pixels per inch or whatever, and I can now just zoom across the map instantaneously. That would be a bad idea. So we want to implement something quite similar for the linear input as well. Let's go ahead and actually write ourselves a task list here. I'm going to be wrapping up here tonight, but I am going to go ahead and write myself a task list to... oh, let's go ahead and stop Unreal from moving things around. But I think we'll have a task list for tomorrow. I will be streaming starting at 7 o'clock tomorrow, probably similar time, 7 to 9. And I'm hoping to do that every weekday except Wednesday. Wednesday I've got other commitments. So, task list 1. Figure out pawn movement, custom pawn movement components. And this is what I was talking about with the character thing. We want to kind of duplicate the character component a little bit for our, or we want to create a kind of a copy of the movement component for our own use. I don't know if we need custom here. We just need to figure out pawn movement components. It wasn't working with a movement component before, but that could have been because we had some mistakes in our code. After that, I want to so we're going to figure out custom pawn movement components, and after that, we want to limit max movement and rotation speed, and then we want to chase the mouse. This is going to be quite similar to Helldivers recently did this, where the your crosshair does not stay perfectly on the mouse, and your character takes time to rotate, and it actually depends on which weapon you're using. And we definitely want to do that for Descent. That's gonna feel better. That's going to make our ships more even with the various different controls. Just going to be better in general. And we want to try and, if we have time, figure out accel and decel curves from Descent source code. So the source code for all 3 Descents is available. Descent 3 was released 2 weeks ago, and that's going to make it possible for us to figure out our velocity, our damping, and our acceleration, our deacceleration, all our velocity curves from Descent itself. And what I really want to get this set up as is Descent 1, 2, and 3 have different velocities for various things. Descent 1 and 2, I think, are a little bit faster in Descent 3, if I recall correctly. And basically, I want to set it up so that you can create ships with custom velocities in it. So creating a mod would allow you to create a new ship that has custom velocity in it. And then by default, we ship with 5 ships: Descent 1, Descent 2, and then the 6 ships: Descent 1, Descent 2, the 3 ships from Descent 3, and then the ship from Descent 3 Mercenaries. Now, to be clear, these are just the code for these ships. The models and stuff for the ships are still copyrighted under Interplay, and you'll have to point the game to the Descent folder to load all those. But that'll be the default, is those 6 ships. But to start with, of course, we're just going to be implementing one of them. And then, as this gets more complex, we'll implement the rest. All right. So I will see those of you tomorrow. Thanks for tuning into the stream. I hope to see you. Yeah, hope to see you tomorrow.